One go. Hello and welcome back to Calculus 1. We have our first lecture, first half, on use substitution, where use substitution is one of the most important techniques of integration in all of calculus. It's not the most powerful one, but it's the one that is there most of the time. And this is the one that is the chain rule backwards. So that's why it has so many problems associated with it. Now, let's first review some of the old stuff, basic integration and so on. So we start by looking at the integral of, let's say, x plus 3 dx. So what is the integral of x? Very good. And what's the integral of 3? Perfect. And then we put plus c at the end. So this is what you learned in 4.9, right? 4.9. And that's that. Now in 4.9 also, we square this. So what do you do now? How do you solve this? And how do you integrate this? You? Come on. No. Well, I mean, eventually. Right now you have, yes, the F word. Foil. Good. So, what? Foil. There is also factoring, but it's foil is the... So we foil. It's x squared. What's funny? I'm serious. X squared plus 6x plus 9 integral dx. So you foil. You get x cubed over 3 plus 6 times x squared over 2. So that's just going to put 3x squared plus 9x plus c. All of this is 4.9. And it's not a problem to solve these things. And here is x plus 3 again in the third integral. And now in this third integral, we put exponent of 64 dx. Foil, anyone? No? I'll be back next year. So, can we multiply this out and then integrate x to the 64 order polynomial? The answer is yes. It's a little bit time consuming, right? It will take some time, but not an issue, right? So you say, is there a way to deal with this so that we don't have to go through so much multiplication? And the answer is yes. When you are solving what we call U sub problems, U substitution, U sub, generally you will always have this attitude of, if this was just one thing, it would be easy. And the attitude comes in here. See this? If this was just x to the 64, then we don't have to think about solving, right? It's just going to be x to the 65 over 65 and you're done, right? So that's where the attitude kicks in mentally. If this x plus 3 was just like one thing, like one variable, we would be able to solve it nicely. So you know what? Let me actually do that. I'm going to replace x plus 3 with u, variable u. And I realize that, yeah, it's going to become u to the 64, but this is still in terms of x. I need to transform that as well. So we are going to differentiate this. And we'll just get 1. Just get 1. And then we move dx to the other side, so du is actually equal to dx in this case. So what you have in this orange rectangle over here is what we call u sub. Because we replaced both x values with u values in this transformation. So now, my new integral is u to the 64 du. And this should be a joke to solve. It's just 60, no, u, there we go, 65 divided by 65 plus c. Remember, plus c is not there for decoration. We have to have that. But are we really done? We're not done. Because the problem was posed in terms of x. You are not allowed to leave the answer in terms of u. So you plug back exactly. So you can say this is x plus 3 raised to the 65 over 65 plus c. You have to do this every single time. You have to go back to original variable, right? You can remember the sentence that says, you can just say to yourself, I don't care about u, I care about the x. And you will remember to plug it in every time. Yes?
That's the final answer.
Yes, are you disappointed?
I'm just surprised you don't have to do anything.
No. Because you did stuff with the interior here to come up with the du. So that's what, yeah.
So in other cases, du could have a more complicated value.
Coming up.
Oh.
Rejoice. Integral of square root of x plus 13 dx. Let's hear it, the attitude. Yeah, if this was just one variable, right? If this was just u, it would be easy. We'll make it a u. U equals x plus 13. du over dx equals to 1. Again, du equals dx. Plug in. I have integral of u to the 1/2 du. Woohoo! This is integral u to the 3/2 over 3/2 equals to, there we go, plus c, which is 2/3 x plus 13 to the 3/2 plus c. We remember from algebra that the exponent 3/2 means 3 is the exponent and 1/2 is the square root, right? So you could, if you want to, you could write this as the square root of x plus 13 squared if you want to, but leaving it as 3/2 is perfectly fine, so it's okay. What else is there for basic examples? What is the integral of e to the 3x dx? Oh, hold on, this was on your exam, all right? I know. So, what is it? E to the 3x over 3. Let's pretend we don't know that. You were supposed to memorize the formula that integral of e to the ax is e to the ax over a plus c. You memorized that. But let's just do our u sub. First, we start with the attitude, right? If that was just an x or a single variable, then I would just have e to the x, and that's easy, right? Well, x is already taken, so let's use u instead. u equals 3x. du, should be doing this blue to keep consistent. If you're writing in pen, I hope you didn't erase it. U equals 3x. Du dx is equal to 3. So du is equal to 3 dx. I don't really have 3 dx. I only have dx. So ship this 3 to the other side. Get rid of it. What's dx equal to? Du over 3. Good. Plug in. We have integral e to the u du over 3. Kick 1/3 outside. Integral e to the u du. That's 1/3 e to the u plus c. Now you go, I don't care about u, I care about the x. So bring back x, and there you go. We did the problem without memorizing the formula. Woohoo! It would be the same calculation if you had sine 5x, sine 5t or whatever, cosine 5t. So integration for all of these would actually drop that 1/3 in front, and you see where it comes from. This derivative for substitution goes there and finally becomes divided by 3. Is it starting to make sense? What happens when you pick wrong? U is not given to you. I try to kind of make it a little bit closer. You know, you're starting with the attitude, oh, it would be so much easier if, you know, so-and-so was happening. That's a good method to approach. More complicated problems, attitude doesn't help. We have a different method. We'll see that. But for the basic ones, attitude is still okay. So, what happens if you make a wrong choice? If you make a wrong choice, you will have extra x's floating around. You will have the worst case to solve than you started off from, right? There is a possibility to pick wrong. And whenever you pick wrong, obviously the problem is not going to work out. Now, what do you do when you run, and you run into a brick wall? No, I said what do you do, not how it feels. You turn around, right, and run the other way. Good. So, nah, it's over. I'm going to stop using this example. The only right answer for this to work as an analogy to the problem is you turn around and run the other way. Not talk about concussions and passing out and getting ice. And okay, you can run towards the ice. There you go.
Okay.
What if you're slow? Then you wouldn't be sitting in this class. There you go. All right. So, anyway. For instance, integral of x square root of 3x squared plus 6 dx. This is level 2. So far, all of our u's had a linear function, right? Now, we have choices. We can pick u to be x. We can pick u to be just the stuff under the root. We can pick u to be the whole root, right? This is why we had to talk about what happens when you run into a brick wall. Because now you have options. And when you have options, One of those options is a good way to do the problem and the rest are not. How do you know? Well, as I said, if the situation gets worse, clearly that's the wrong choice. So it's kind of scary that that's one of the ways that doctors approach the situation, right? You go to the doctor and say, hey, here, try this medication, right? We'll see what happens in a week. You come back, now you're bleeding from the left eye in addition to whatever you had. And it's like, okay, we'll change this and then give you something for the eye as well. Yeah, right? This over here, you know immediately on the first step. The concerning thing is that some of you were nodding your heads as I was giving the example with the doctor, which doesn't make me happy, but it did prove the point. Anyway, what is the key to solving these problems when they're more complicated? We look for what I call function derivative pair. You see, the derivative of x squared is a single x. Yeah, I know there are numbers involved, but we don't care. We can fix that. One thing you can't fix are variables. So, if you take a look, you have a function x squared, and then you have a single x. And I call that function derivative pair, and your function is always u. Because its derivative, that it's also present, is going to stay as a du part. Because du comes from the derivative. Bueno? So, I will set u to be 3x squared plus 6. And the du over dx, in this case, is 6x. Giving me that du is 6x dx. Note that I don't have 6x dx. I have x dx. I can fix the issue with 6. We can fix it by dividing over here by 6. That's a way to have du over 6. Or, my favorite way, fixing the integral. What do I need? I need 6x dx. Yeah, just put the 6 in. There you go. Now it's 6x dx. And then you balance it out with this one in front. So this is the fixed method. I like this one because it gets me to write less. Because over here I would have to now write another line with x dx equals du over 6. Then when I plug in the problem, it will be du over 6. Then I would have to have another step to pull that 1 over 6 outside. I didn't sign up for gym, right? I signed up to do the problem in the least amount of steps we can. So, put the 6 in, put the 1 over 6 outside. Every time you need to fudge a constant, that's it. Right? A number there times, and then divide the same thing outside. So now, I have my 6x dx, and that's going to replace into du, and I have root of u. So, now we're going to plug everything in. 1 over 6 integral square root of u du. And I'm going to underline orange the substitution that replaced. You have to chase it around, right? It's visual. So I have 6x dx become du, and the mess under the square root is now u. Wow, we took this integral that was all over the place and transformed it into something that we can deal with quickly. I have 1 over 6 integral of u to the 1/2 du, which is 1 over 6 u to the 3/2 over 3/2 plus c. And then we just bring back x variable. So this is going to be 1 over 6 times 2 over 3. 3x squared plus 6 raised to the 3/2 plus c. Finally, these cancel, so this is 1 over 9. 3x squared plus 6. 3/2 plus c. What happened?
You see how you get rid of the f1 over 6 and the square of u du? How do you get rid of the x?
This x?
Yeah.
It's a part of du.
Okay.
So it gets replaced as a block. You know when you're swapping an engine part or a computer component, right? You don't. If you want to swap graphics card, you don't go and take off, right? Solder off the processor and the RAM, and right? No, you just take the whole card out, right? So this is it, like one unit. Just drop it in instead of those. Just dropping it in, and that's du. That's why I color code orange, right? Because that's the replacement that happened. It's a little bit more chasing around than you used to. Now, the problem is done, and you are proud, right? Is this good? And how do we check? We take the derivative of our answer. If we get this without the red 6, we're good. If we don't get that, well, something is wrong. And it stinks when you don't do the derivative right. So you think integration was wrong, and it turns out it was right. So anyway, so let's check the problem. That's going to be green. By taking the derivative of 1 over 9, 3x squared plus 6 raised to the 3/2 plus c. We'll take the derivative of this, and hopefully we get our original problem. All right, let's go. 1 over 9 is a constant, copy, times 3/2 exponents drops down. We keep the 3x squared plus 6 for now. And then get 1/2, right, because minus 1. Then times the derivative of the inside, which is 6x. And then plus derivative of c is 0. Are we all green on this? Good. Now, I have 3 times 6x, that's 18x, divided by 9 times 2 is also 18. And then this one is good old square root of 3x squared plus 6. 18 cancels, and there's your x times the square root. Woohoo. So it's good. We got our problem back. And this is why, as a student, I loved integration more than derivatives. Because derivatives, you do the derivative, and then you look at it and say, yeah, it's good. Right? And you move along. There's nothing else you can do unless you're going to sit there for 10 years and work out the limit, right? F of x plus h. You take the derivative. Maybe there is another way to take the same derivative, right? You take the derivative using product rule and then say, but I can also do logarithmic differentiation, and you try that one. You get the same answer. But see, for integration, you do the integral, and then you can differentiate to check if the problem is good. And since we got exactly this, that's good. It's good. Yeah, but usually you don't have the access to integration until, yeah. So I'm going to give you guys a problem to enjoy. How about the integral of x squared times e to the x cubed minus 18 dx? Have fun. No coffee. You can drown that way. It was not funny until you sealed the deal.
You should know take a picture of security number. That was good.
You pay for the check? True, right? True that. True that.
Alright, so let's take a look at this problem together. We have the exponent on e. If this was just one thing, right? So let's go. U equals x cubed minus 18. Du equals 3x squared dx. So I immediately shift dx to the other side because it's faster. I don't have 3 in front of x squared. So what do? Magic, right? 3. And then 1/3 in front. So we fix it. Now, don't fix your original integral unless you have a different color pen. So you know that you place that stuff in. If you don't have a different color pen, just write another integral and then put the 3 in. So now we have 1/3 integral e to the u du. Again, orange. These guys combined into du because of the transformation over there. And now we have 1/3 e to u plus c. Now I don't care about u, I care about the x. Plus c, and there you go. Good timing. Never mind.
I was going to ask about the 3x squared dx in the original equation, and du, and c.
Good. Let's see what else. We haven't done any trig. I know how much you love trig. Look at that attitude. Love it. All right, great. Here we go. Cosine to the 8th x sine x dx. Do we have a function derivative pair? Good. So now what?
I get it.
What happened?
U is sin x, and then du dx is cosine.
All right. So u is sine x, and then du is derivative of sine is cosine x, and we put dx. Good. So now, when I plug this in, I will have, well, sine x is going to give me u. I'll take one of the cosines from here, which leaves me 7 cosines around, and make this du. Doesn't look too hot, huh? So what now? This is the brick wall, right? What do we do?
Move the 8 on the second.
Ah, u equal cosine x. Okay. So this didn't work out. U equal cosine x. Which means we get negative sine x dx. On, yes. Great. So now, negative integral cosine x is u, so u to the 8 du. Do we all see it now? Perfect. And what's u to the 8 integral? Plus c. Guys, is either plus c or minus 1? Right? On a test, I mean. Yeah. Uh-huh. It's plus c or minus 1. On a test. If there is no plus c, I put minus 1 like this.
Oh, yeah. I thought you were saying it's plus c equal to minus 1.
So now we have negative 1 over 9 cosine to the 9x plus c. And that's the answer. Word? Okay. So, that's all I heard. Word, even though these are... Right.
I said hooray.
Okay. Thank you. X to the 9 cosine x to the 10 dx. Do we have function derivative pair?
Yeah.
What is the function derivative pair? X to the 10 with x to the 9. Very good. So what's u? X to the 10th. There's no sines and cosines here as a pair. There's no sine to pair up the cosine, right? Can't have Robin without Batman. Makes no sense. What? So we don't have a 10. You notice how I write these integrals? I always leave space there because I know I'll have to sneak in a number. So 10 and 1 over 10. This gives me 1 over 10 integral cosine u du. What is integral of cosine? Okay, so half of the classroom said negative, the other one didn't say negative, so what are we going to do?
It's integral.
We're gonna take it outside or what? It's sine, good. So it's positive. Good. The entire method is a lot of examples. Just keep working on examples, example after example after example. I will also mention one more time. Use YouTube. Type in use substitution. Let me see. YouTube. Use substitution. They used to say how many videos, how many hits. They don't say that anymore? No, they used to say how many hits you have for the search that you are. And it's going to be over 100,000 videos on it. Now, what is the way to do this? You search for a perfect example, like this one, where you only see the example, the white one on the top. Click on it.
In this tutorial, I'm going to discuss integration by
Stop. This is how you learn with YouTube. Immediately, when you start the problem, you see the problem, immediately stop. Write the integral, keep doing it on your own. You get stuck, you don't know what to do, or you finish the whole problem. Play. When you hit the issue, you resolve the issue. If there are mistakes along the way, you are following the steps, right? And
the derivative of x squared.
And then you follow along. So it doesn't matter whether it's a full lecture, whether it's a single example. The key is to pause the video, go through it as much as you can, and then if you get stuck or you have issue, whatever, then play it, get to the point, pause it immediately, continue working on it, and then your goal is to get through a few of these. How are these suggested things that are coming up next after the use substitution? The color city and all dogs are whatever. This is not, I'm not logged in. I'm not signed in, so.
Who is? Really wants you to watch Igor. You can watch him free with ads now.
All right, fine. Whatever. So that's that. Everything okay? Okay. Let's pick more examples. Now I want to work on examples from the book. So let's take a look at some of the a bit spicier problems. Let's start with problem 34. Integral of 8x plus 6 divided by 2x squared plus 3x dx. So what is this equal to? What's u? 2x squared plus 3x, good. And what's du? 4x plus 3, everything in parentheses dx, because it's times dx. Those parentheses there are not for decoration. We need them. I don't have 4x plus 3. Or we can just factor 2. Kick in front of the... So factor 2, kick in front of the integral. We'll get 4x plus 3 divided by 2x squared plus 3x dx. Now when we substitute, we are going to get 2 integral of du divided by u. Close? Close? Absolute value, thank you very much. So 2 ln absolute value u plus c. A lot of minus ones on the test because you forgot absolute values. So we have 2 ln absolute 2x squared plus 3x plus c. Now, I know that this problem didn't go too well on the test, so I'm going to write the formula from 4.9 integral of dx over x is ln absolute x plus c. Also, you can see it as integral over 1 over x dx. It's the same thing. Ln absolute x plus c. So whatever form you run into, whether it's dx over x or, right, because it's times dx. That's why. Yeah. I'm sorry? It's 1 over, right? You can see that it's the same form. So I gave you 4.9 formula, which is the backwards derivative formula we learned for ln. And trust me, you will be sick of ln integrals as soon as you hit the Calc 2. There's a whole section on partial fraction decomposition, which was going to go into your differential equations course, where pretty much every single one is ln. So there's going to be a lot of ln integrals coming up. Nested ln integrals, that too. So that was problem 34. Let's take a look at problem 20. Problem 20 says, lock the doors. Square root of x plus 1 to the 4th power divided by 2 square root of x dx. You know the beautiful thing about the upcoming final and this integration? The integral is either basic, which is 4.9, or u sub. Do you know what problem of chapter 7 in Calc 2 is? Integral can be those, or by parts, trig sub, trig integral, integration by partial fraction decomposition. See that? A little bit tricky. So right now, integral is either basic or it's u sub. Clearly not basic, right? Integral of square root of x is basic. That is clearly some kind of u sub, because that's the only other thing you know. It's either a cheap integral from 4.9 or u sub. Your job is to sit there and figure out what that u is. So at least you don't have to pick between 6 different methods, right? You immediately, within 2 seconds of looking at it, should know whether it's a basic integral sine x, or is this u sub. So what's u? Square root of x plus 1. And what's du? 2 dx. Good. So now, in this peanut over here, I have my du. So integral of u to the 4 du, which is u to the 5 over 5 plus c, easy peasy. I want to do a little bit more of this level 1. This is all level 1. This is level 2. Definite integrals. And then hard problems after that. Ooh. 30. Integral of dx divided by 1 plus 4x squared. This one is really tricky. What happened? Wow, nice. Boss, right there. Boss. I tried to trick you with this one. You see that you need, if you want to put this as you need x on top. Do you have x on top? Anyone want to check? No? No x on top.
1 over that times the x.
Yeah, but still no x on top.
Right, yeah.
So, and you solved it. Arctangent. Arctangent is 1 over 1 plus x squared. I told you you gotta know that one. Not just this class. This is one problem. Don't worry about it. Calc2 is coming up. Differential equations coming up. An arctangent plays a role. All right. So you gotta know that one. So what do we have? I'll write here again. This is 4.9 integral of 1 over 1 plus x squared dx. So vanilla x squared. no 4, is arctangent, inverse tangent of x plus c. Now, when you compare the two, attitude kicks in. Ugh, right, for 4x squared. So what do? We write this as integral. You can put dx on the side if it bothers you. 2x squared dx. So you see now, attitude kicks in to remove this x squared and make it a single variable. Because now if I have 1 over 1 plus u squared, that looks the same. Do we all agree? So this mathematical manipulation that we did allows us to use the u sub and create the arctangent answer. So what's the correct u sub over here? Correct u sub is u equals 2x du equals 2 dx. I don't have the 2, so I'll fix that. Put 2 on top and 1/2 in front. And now do the rest. So now it's 1/2 integral. Now I have 2 dx. That's going to be du. I have 1 over 1 plus u squared du, which is 1/2 inverse tangent of u plus c, which is 1/2 inverse tangent of 2x plus c, as you have foreseen. Cool, right? Of course, it's math. What happened? Because u is 2x. Because I need everything to be squared. Only x is squared here. So I make 4 into 2 squared and then go from there. Let's see if we can. Ooh. I love problem when I see it, I have no clue what to do. Let's go. X to the 3/2 plus 8 raised to the 5th power times the square root of x dx.
So I can see if you written that one.
The formula from 4.9. So what's u? Good. X to the 3/2 plus 8. So u equals x to the 3/2 plus 8. du is
3/2 square root of x dx.
so we don't have this 3/2. We put 3/2 and then 2/3 on the outside. So you have 2/3 integral u to the 5 du. Again, orange, so we can trace this du. Two-thirds u to the 6/6 plus c, which is 2 and it cancels, so 1/9. Then instead of u we have x to the 3/2 plus 8, everything raised to the 6 plus c. Sounds good? So what's going to happen on Thursday? Second part of this lecture. We're going to take a look at solving these on definite integrals. We have additional step for definite integrals. When we switch integral from x domain into u domain, remember that the limits are x1 to x2. We have to switch those to u1 and u2. We do not have to go back to x. We will compute in u domain because we change the limits into u domain as well. So we change the function to u, we change dx to du, and we change limits from x1 and x2 to u1 and u2. So that's next class. And then we'll try to do some scary problems in prep for, not for the final, but for the next chapter of life. Also, I'm going to give you the list of topics and formulas and things that you are going to ruin your winter break with, so you are prepared for Calc 2. So when you walk in, you don't fall off the truck in the first 2 weeks. I will give you exactly which trigonometric identities you must memorize. Exactly what types of trigonometric equations you need to be able to solve. And then we'll take a look at some other Calculus 1 concepts. There's just going to be a list of things that you are frequently use in Calc 2, like chain rule, 4.9, 5.2, 5.5. So I will give you a detailed list of things to practice. And then, over the break, if you have good will and you think about these kind of things and you want to get ahead and have a very strong foundation, because you all heard horror stories about a Calc 2 class, and that's next. Now, that class is nothing if you have a good base. Nothing. You don't have to worry about Calc 2 at all if you come in prepared. But if you come into that class with trig being, a year-old thing that you have, or more, that you haven't seen, and the only way to solve a problem is if you know Pythagorean identity, if you know power-reducing formulas, which you need to know like this in order to solve the problems, and you don't know that, clearly you can't do well in that class, and then, it doesn't work well. So we'll cover all of that next time on Thursday, which is our last class. And then the next week, right, so 9 days from today, is going to be the final exam. I believe at 5:30, you said?
Yeah.
So 5:30 is going to be the final exam, and the course is over. So see you this Thursday, see you next Thursday. You stop by office hours, I'll see you then. Don't forget the project is due the day of the final, so if you are not working on a project yet, you are doomed, but do at least something. And see you all. Bye.